Sorry, yeah.
Perfect. Okay, just wanted to make sure. Okay, so all right, let's see here. I think just want to make sure I'm. Yeah. Okay. All right. Good afternoon, everyone. As Deb mentioned, I've been presenting quite a lot in these Badgerland user groups, and last time we did Creo tips and tricks, I believe, and this time it's going to be on the simulation tools, two new exciting ones that I personally was an analyst during my industry days, so I really like these two tools that PTC has. Those who don't know me, my name is Thiago Pleniap, and I work for Tristar. Those who are not familiar with Tristar, real quick, we are a company that specializes in helping manufacturing companies adopt software systems and processes, right, to enable or allow better and more efficient product development. And we do that by being the largest value-added resellers worldwide for PTC, right? We're headquartered in Phoenix, in Arizona. I'm based out of the Chicagoland area, been here for several years now. I started with the old Pro Engineer version 16 back in '96, was in the industry for a good part of my career. So at Tristar, we do have a team of engineers that are spread across the United States and Canada. And we help with eventual implementation on the CAD side, with simulation, as well as with new custom products. So it's a quick overview about our company. Now, from an agenda standpoint, as always, I wanted to make sure that we maximize the time, and I want to show you as much as possible using the software. But some of you may or may not be familiar with these, with the PTC's new ANSYS partnership. So what I wanted to go over initially is maybe like a computer-aided engineering landscape in Creo, right? What are the options there? Very high level, and then we'll get into the big partnership that happened like 2 years ago or 2.5 years ago between PTC and ANSYS, and then the two tools, which is Creo Simulation Live, and then there's also a new one they introduced in Creo 7 called Creo ANSYS Simulation, which is more for high fidelity. Some of you may be experienced, some of you may not be experienced in FEA. So it's gonna two solutions for different use cases there, right? And I had a Q&A towards the end, but feel free to start. I know that all of you are muted right now, like Deb mentioned, but please feel free to start typing in your questions in the chat session. Maybe towards the end, I'll try my best to just go over those and try my best to answer those questions as much as I can. Those who some of you may, again, you may be using Creo for some time or the old Pro Engineer. So I thought of this, talking through this slide real quick on the computer-aided engineering landscape in Creo, right? We do know that the old Pro Engineer as well as the new Creo has had Pro Mechanica or Creo Simulate, as they call it. And then there are a variety of other simulation tools like mechanism design, mechanism dynamics for force and calculations or reaction calculations, right? Then there's MathCAD, there's tolerance analysis. They call it now easy tolerance analysis for 1D tolerance stack up. So this is the overview of the current options you have from an analysis standpoint, right? There are a few other things that I've not even mentioned here. And here, yeah, there's like behavioral modeling extension or BMX for optimization or design optimization. But during this presentation, I thought I want to focus mainly on this PTC's and partnership with ANSYS, mainly on their two tools. One is a live simulation, called it Creo Simulation Live, and then this new ANSYS simulation introduced in Creo 7.0.2, one of the latest gate codes of Creo. So 2.5 years ago, PTC kind of embedded, or I should say they started giving they came up with a new tool called Creo Simulation Live, which is essentially ANSYS Discovery Live embedded inside of Creo, fully integrated, right? So you're able to make instant changes, instant feedback of your designs rather than doing the typical, pre-processing, post-processing, solving. It's using GPU-based computing, so real-time feedback for designers and engineers that may not be FEA experienced, but still would like to get the ANSYS technology in their hands as they're doing their design, right? During the initial stages. That's very helpful. So So they started, we all know PTC has been out there for some time, right? Like 25, 30 years. And then we do know ANSYS has been doing simulation for a long time. So it was nice to see both of them partnered together to come up with these two tools in here. One is ANSYS simulation, and the other one is Creo simulation live, right? And I'll go through examples, multiple ones of both of them one by one here. So real quick, before I show you some examples, Creo simulation live is supported since Creo 4.0, the MO90 date codes. It's there in 4, 5, 6, 7, and of course 8 will be out in like a couple of months from now, or in a month, next month probably. It's mainly meant as a directional tool. So it's more for some quick feedback as I'm making changes, right? I want to do some what if scenarios and give me some direction as a designer or as an engineer if I'm going in the right direction. That's really what Creo Simulation Live is meant to be, right? Very, very quick. You don't even have a solve button, right? You just say, apply the loads constraints, and then you just hit show me the results. That's how quick it is, because it's leveraging not the CPU that traditional FES software uses. We are using the GPU, right? So there's a requirement for the GPU graphics card, and we will go over that too. And then they also came up with this new tool called Creo ANSYS simulation, starting Creo 7, which is more for some of you may be more experienced in FEA, and you'd like to have a much more of a higher fidelity, higher accurate solution, more than just being a directional tool. So more for somebody that may not be an analyst or maybe a part-time analyst at the same time you are doing design work, but you'd like to know to go a little bit beyond Creo Simulation Live, and that's Creo ANSYS simulation. So really there are two tools here that I wanted to quickly go over. It's really the ANSYS discovery that many of you may have heard of when ANSYS came out with this groundbreaking product about 2.5 years ago, and PTC has kind of integrated that fully inside. That's the engine that's driving Creo Simulation Live. And you can do structural, thermal, modal, and also fluid flow starting Creo 7. And then ANSYS simulation is, okay, some of you would still prefer to refine the mesh. You'd still like to apply contacts and joints, and you may want to have some more additional capability. That's when the Creo ANSYS simulation takes over, wherein that's more meant for the final validation phase. That is using traditional CPU. It could leverage a GPU for the results, but mainly it's your traditional FEA tool, but it's ANSYS powered, integrated inside of Creo Parametric. So let's take just to give you a quick look in here. I know I do have an NVIDIA graphics card that has about 4 gig of video RAM. That's one important requirement. I mean, PTC recommends 8 gig, but their minimum requirement is 4 gig of video RAM on the GPU. That's what is really giving you results in quick time. That is one of the biggest advantages of using Creo Simulation Live, right? So take a quick break from this, from the presentation. I'll get back to it in a bit here, and let me go up to Creo. So what I have is 7030. PTC just last week or this week, they released the latest date code. I just have that. And I'm going to open up a very simple file first in here. Let me see if I could open up a part. I can do parts and assemblies. And I got as you can see, as simple as you can get, a very simple part in here. And first, let's take a look at the Creo Simulation Live products. I'm going to go to Live Simulation, and as you can see here, I do have a structural analysis and a modal analysis set up. And all I've done is I've fixed it at the bottom, and I've applied a load through that hole right there, right? If you see the load that I applied is about so much values, 100 pounds is what I've applied there, and I'd like to know what is a stress, what is a deformation, and I just hit this little button here. So there's really literally no meshing or solving or run button, right? Technically, all you're doing is constraints, loads, and then you're just saying, show me the results, right? So when you do show the results, what is kind of happening there is it is making use of the GPU, right? So the more the video RAM, the better video RAM you have on your graphics card, it's going to be faster and more accurate, right? And you can control the performance in here. You can see there's a little slider here. You can push it to the right, as you can see here. You want to have it more accurate or faster solution. So that is a simple part. It came out pretty quick in there. And it's giving me like obviously my von Mises stress, right? So maybe this is something I would compare against the yield strength of steel. That's the maximum. I could have it, show me where the maximum is. I could also have it do the usual animation, right? Look at the deformation, etc. Right? So that's there. One thing I'd like to do is maybe this is something that it looks like I'm in a different environment, like in a simulation environment or a live simulation environment. But I could just be in my regular modeling environment too, right? I could be in this environment here and I could start just saying, okay, so I have a sharp edge there and maybe I should add a round. And I'm just in my regular design environment here where I'm adding the round, adding some fillet or something there, right? I'm adding a quick round feature there and that's pretty much it. It goes back to blue. It's the software is essentially doing the analysis in real time and giving me feedback as to will the stress, okay, it did decrease a bit, not as much as I would expect it. So maybe I don't think I want that. I'm going to probably go and instead of that, could we try other things? So I'm in my regular design environment and I'm not, really spending time going into in a simulation environment, spending time or meshing it and all that. I want some quick feedback. Am I going the right direction? That's really what I want here, right? Maybe I have a little rib in here that I've suppressed. I could have created manually too. So as you can see, that rib is being resumed. And now all the way from 70 megapascal, that has really come down to about 2 megapascals in there. And obviously it's having a little more, added some more strength in there. That makes sense. But it's more like I can keep changing this and I get immediate feedback, right? So that's really what this GPU-based Creo Simulation Live does, or helps designers with, right? I'm in my Creo modeling environment and I'm able to turn off and on results, right? That's pretty straightforward, right? Now, just to go over in an assembly, right? It's not just on parts. I mean, just to give you another example on a typical part, this also helps for like design exploration or in your concept design stage, right? There could be situations where, as you can see, I'm taking the role of a designer who doesn't have FEA experience, but I might want to create the support plate real quick and I'm going to activate that. I'm in my assembly mode and, I'm in my regular day-to-day design activities here, right? I do have a few sketches already done, but I'm thinking I'm probably going to use this guy here for my extrude, right? I'm going to just extrude that, shift selected, that snaps to it. I'm going to go right mouse click, go to my site 2. And I'm going to just go say, okay, let's go up to that point. And at this point, I'm thinking, okay, I've not done my fillets, I've not done my ribs or nothing in here. Am I going in the right direction, right? That's all I want, right? I may not want to have a very high accurate solution, but just give me a ballpark of what would be the stress right now. If I put in about 100 pounds on that face, what would be the stress? That's really what I'm interested in, right? So I'm like in the early design stages where I am in, right? So I'm going to go back to my live simulation, and it's loading its, the Creo Simulation Live. There it is, right? It's pretty straightforward. And I'm going to go and use my mini toolbar, just like your regular Creo parametric environment, right? I'm going to fix that guy there. I'm going to just say, let's apply a load. We'll just go give it there's my triad in there, right? Y-axis going up, so I can just go, let's see here, I can go give it a negative value, right? I'm just giving it some 100 pounds or some value. Then at this point, I'm just going to say, okay, let's see what happens, right? I just say, show me the result. So this is something I didn't set up anything, right? Unlike the previous bracket, I just really created, I had a couple extrudes done, and I'm looking at the stress in here, and it says it's about 17 megapascal, right? Right in there. Now I'm thinking, okay, I'm going back to my design mode, or I'm in Creo and saying, okay, what happens if I redefine that extrude and use this shape instead, right? So I'm essentially having multiple external sketches here, right? I'm sure all of you, in Creo, you have the ability to, one of the advantages of external sketches that you could use any one of them and you can drive your design, right? That's really what I'm doing here real quick, right? So there it is. I'm going to go to shape 2. And I didn't have to go say run or regenerate. I'm out of that mode and immediately it's kicking in here and it's saying it's 50. So what I could do, I could even keep track of these, right? So for example, let me just get out of this. I'm going to go back to redefine here. I'm going to go back to the shape 1 that I had. It's almost like I'm exploring these. I could either do a design exploration session at this point, or inside of my live simulation, I could add probes in there. So I could just say, okay, let's add a maximum stress on this entire model, right? There is a von Mises stress. You know, it's kind of showing where that maximum von Mises stress is there. I'm going to save that. There it is. It's 17 megapascal right now. I'm going to also say accumulate the data when I make changes to it, right? So what that is going to do is if I click in here, it's kind of keeping track. It's like graphically, what is the stress right now, right? It's just a quick report it's giving me. Now I could just go back and say, okay, let's do all those different variations, right? I might want to say, okay, let's try this one instead of that shape. I redefined it. It's kicking in real time. It's kind of saying, okay, from, you know, looks like that didn't help at all, right? From 17, it jumped up to 50, right in there. If I look at my, there it goes, right? It's increased in there right now, right? Or maybe I could just say, okay, let's go redefine it to, let's see here, this shape in here, and let's see if that helps a bit. This is during the initial design stage, it's kind of very useful. I think it's back to 15. That's good news, right? Better than before. And then I can maybe, let's see if I have a few sketches done in here. There's another, you know, a little more of a different shape with a couple of arcs in there. That seems to, again, I'm just allowing it to settle in there. You know, the results are just takes literally in a few seconds in there. It gives me that it's backed up to 52. So there it is, right? I'm looking at my the history and saying, okay, we went from there to here to there, and we're still in the process, right? I'm thinking, you know, I would rather just use that original shape that we had here, right? That's probably what I'm going to do for now. And maybe we'll try to improve upon this, right? So it says, where's my max minimum, right? It says there's a maximum, and maybe I could start adding and throwing in some rounds like before, right? So maybe in the other model we did we'll just add some rounds in there. Let's see if it helps. We'll probably add a fillet or a chamfer on the other side. And it helps. It did help, as you can see. It's come down to 14 right there, the maximum stress. I'm going to go back and say, let's add a chamfer in here. I really like these new mini toolbars that TTC introduced in Creo 6, everything right on the mouse cursor. So just do a little D1 by D2 kind of, let's see, a chamfer. Let's add some material essentially there to help with the stress. And now the stress is back on the other side in there, but it's decreasing. We are making some progress as we speak here, right? And if I look at my design states right in there, and you know, I do see that okay, we tried with the first iteration, then went up there, and then came down, and then we are going in the right direction. See, that's what I was talking about more, that it's a directional tool, right? Now I might still want it to have it below 10, or I might have some yield strength criteria. And this is when in my modeling environment, right, I do have a datum plane in here where I'm going to use that to create a rib, a profile rib, right? Ribs should help, you know, obviously strengthen this. It's going to add weight, obviously, but let's try it out, right? So I'm going to go add, just use the Alt and grab these guys real quick. You know, holding Alt kind of essentially allows you to select references as you sketch. Right, there it is. Just did an open sketch because for a profile rib, you have to have an open sketch, right? So these are all regular design things that I'm doing here. And once I'm done, the analysis was on, right? It kicked in and it said it brought it up, right? Actually, it from 12, it's back up to 17. And I'm thinking, you know, let's just add a few more ribs and see if that helps, right? I'm going to do a pattern. There are different types of pattern, right? The direction, axis, all that is right in your mini toolbar here. I'm going to just say, let's do a direction pattern and set it to, let's see here, about 3 or so, right? I've increased the strength, obviously, hopefully now, and we'll just wait for it. Yeah, it did bring it down to 13, but it's, you know, we are still a little higher than where we were, and I'm thinking, okay, you know, all these are some common sense, you know, design things that we normally do, right? Okay, so, but we have to have an idea of what's going on, what is the stress, what is the deflection, maybe I'm going to increase it a bit here, and we'll see if that helps. You know, you're adding more material and a little more stiffness due to that geometry there. It's making it a little more stiffer in a sense. And that did bring it down to 6.7 megapascals. So if I look at my history here, right, and I can export this to Excel and all that, right? So, but you get an idea of why I call this a directional tool, where I'm not even, you know, I might still need to do a lot of features, some mounting holes. You know, I'm not yet through with my design, but at a very early stage, I'm able to, you know, look at some of the information, just some feedback, right? That's the advantage. Now, I can always go back. Now that I know I'm in a position where I could move forward, I could say, okay, what about the interior assembly? Those parts are great, but what about the interior assembly itself? And I can just go and say, maybe let's mirror this guy onto the other side, right? So maybe I want to go into use one of the planes for mirroring it. Just do a little preview. There it goes. You know, created a left-hand side, right-hand side kind of a part right there. Might do some changes on the other side maybe, but I could do the overall assembly, or in assembly, there was a way to import a part level study into an assembly. That's very useful for scoping the design. For example, I could just go and say, instead of doing a new one, I could just go import existing simulation, right, from the part level to the assembly level. Quite useful to look at it. So this part, we already did an FEA. I just want to grab that study into my assembly right there, right? That's the one. And I'm going to go activate that. And I'm also going to make sure the scope is just this part, right? I don't want you to worry about the interior assembly, just this part. And I do the same live simulation again, and it kind of gives me an idea of the stress. At the same time, it's only showing me the stresses on that part alone in the context of the assembly. So you could scope this. The scope feature very, very useful, introduced in Creo 6.0 in Creo Simulation Live, where you can scope specific components that you're interested in, right? And that's where it's really active, you know. So even if I do my animation and deformation, as you can see, it's really not taking into account everything in there, but in the assembly mode, I want to have an idea of how the part behaves. That's really what I'm looking at here. Now, I might say that, okay, once I might go back to my to another analysis here, I can always create a new analysis, right? Any number of studies in here, structural, thermal, model. But this time, I probably want to run the entire assembly. You know, let's see how fast that is going to be. The parts look pretty quick, and I know. Let's see. So I'm going to go and not activate, but I'm just going to go back to live simulation, and we'll just fix this guy here at the bottom. We'll just assume that's fixed. And I'm going to go add a force up on this surface, let's say here, and we'll just go give it a couple of, just bear with me while I add some, just give a -100 in here. I'm just using my triad in here, right? You know, we'll just apply downward, and then maybe the Z direction will apply 100. So the resultant will be at like 45 degree right there, as you can see. And once all the materials are assigned, you know, I've already assigned the materials for all the parts in here in the assembly, you just hit the simulation show results. And this takes a few more seconds, as you can see, compared to all the two demos I did so far, the parts, right, the individual ones, but it does work with the assembly as well, right? So that is pretty quick, right? Normally, the time you would take to even mesh an assembly like this in either a Creo Simulate or a traditional FEA tool does take time. But this one gives you some quick feedback there. Again, I'm going to go to my deformation analysis. And the thing here is, though, is we are assuming they're all bonded, right? So I'm assuming that this is bonded or welded. And in the real world, that may not be. And that's when, you know, a full-blown Creo ANSYS simulation might be a better fit. But it does give you results for assemblies like this as well, right? So that's one thing. Now this is not a very complex assembly. It's not a lot of parts in here, right? If you look at the number of parts, not a whole lot. But imagine if I could just close this one here, and if I opened up, let's see if I could open up another one in here. Let's see if I could open up an assembly. This one here, this guy here. It's a rear axle, kind of like an assembly that has a lot more components in here, right? As you can see, if I go to my selection filter and search for parts or look for parts, there it is. It tells me 54 selected. If I double click on that, it kind of tells me, there's about, most of them, some of them are hardware, obviously, but still, it is the geometry itself is a little more complex, where many times you'll have to, during my analysis days, when I get a model like this from the designer or the engineer and I have to do an analysis, I'll have to first de-feature it and even to keep the mesh working and all that, right? So here I just go to live simulation, and I've already applied, a load and constrained it. No need to mesh or anything. You're just, again, leveraging the GPU. And I'm saying, give me the results or show me the results, right? Like I said, there's no run. It is running. I mean, it's leveraging ANSYS proprietary, discovery engine is what is working behind the scenes in here. It's leveraging your GPU. So you will need an NVIDIA CUDA-based graphics card because that's critical, or it's very important. It's a prerequisite to use Creo live simulation, since it's not using the CPU, it's using the GPU. And as you can see here, it came out pretty well for a large assembly like that. I mean, quick time. And of course, I can, again, switch to deformations or stresses. I can do the same probes at specific areas of interest, or maybe I might just say, okay, that's the only thing. I want to isolate that guy and just look at that component alone. And, you're able to do all that. So again, from an assembly or a complexity standpoint, they're all bonded, and you just want to have some overall direction as to, are you going the right direction, the design, what are my stresses, deflection. It's kind of useful in that way, right? So that's just to give you